For most of history, Mercury was the overlooked planet. A tiny barren rock huddled next to our sun. It seemed to lack the drama of Jupiter's storms or the mystique of Mars's red deserts. We saw it as a crater-faced world, baked on one side and frozen on the other. But what if that's not the whole story? What if I told you that a few scientists looking at the data from NASA's Messenger mission have proposed something that sounds more like science fiction than astronomy? They've asked a wild question. Could Mercury be hiding a glittering secret deep inside? We're not talking about a few scattered gems. We're talking about a fascinating and highly debated hypothesis that a massive layer of solid diamond could be blanketing its core. This idea is a scientific longshot, but it's pushing the boundaries of what we thought we knew about how planets are made. So, how could this even be possible? And what would it mean if the smallest planet in our solar system is secretly the most brilliant? To understand this wild idea, let's quickly revisit the Mercury we know. It's a world of extremes. With almost no atmosphere, its surface temperature swings from a blistering 430 degrees Celsius at noon to a frigid minus 180 degrees at night. Its face is scarred with craters, looking a lot like our moon, a record of billions of years of cosmic bombardment. But even before this diamond theory, Mercury was a puzzle. For its tiny size, it's incredibly dense, the second densest planet in the solar system right after Earth. That's because it's hiding a ridiculously large metallic core. While Earth's core makes up about 17% of its volume, Mercury's core takes up an estimated 57%. It's less of a rocky planet with a metal center, and more of a giant metal cannonball with a thin rocky coating. Our first good look came from NASA's Mariner 10 mission in the 70s. But it was the Messenger mission, which orbited Mercury from 2011 to 2015, that truly changed the game. Messenger mapped the surface, analyzed its chemistry, and measured its gravity in stunning detail. And it was in that treasured trove of data that scientists found the clues that sparked this incredible new hypothesis. The data confirmed the huge core, but it also deepened an anomaly that scientists had been struggling to explain for years. Every good story needs a mystery, and Mercury has two big ones. First, why is its core so enormous? The leading theory is a cosmic hit and run. Billions of years ago, a massive object may have slammed into a young Mercury, blasting away much of its original crust and mantle, leaving behind the dense, metal-heavy planet we see today. But that might not be the whole story. Some newer research suggests the Sun's intense magnetism in the early solar system may have also played a role in sorting elements and leaving Mercury with an oversized iron heart. The second, and maybe bigger mystery, is its magnetic field. Earth has a powerful magnetic field generated by our churning molten outer core, a process called a dynamo. Mars, which is bigger than Mercury, once had a magnetic field, but its core cooled and froze billions of years ago, shutting its dynamo down. According to all the classic models, a small planet like Mercury should have cooled off eons ago. Its core should be a solid, frozen lump of iron incapable of generating a magnetic field, and yet it has one. It's weak, only about 1% of Earth's. But it's there and it's stable. This shouldn't be possible. It implies that Mercury's core, against all odds, is still partially molten and stirring. For decades, scientists have tried to figure out how this little planet keeps its engine running. It's a puzzle that demanded a creative, out-of-the-box solution. And one of those solutions happens to involve the most glamorous substance in the universe. The first hint that something strange was happening inside Mercury didn't come from deep within, but from its surface. As Messenger's instruments scanned the planet, they found something unexpected mixed in with the rock: graphite. Yet, the same soft gray carbon that's in your pencil lead. On Earth, most of our carbon is in the atmosphere or locked up in rocks, but Mercury seems to be a fundamentally carbon-rich world. The graphite on its surface is thought to be the leftovers of an ancient global ocean of magma that was saturated with carbon. This discovery was a game changer. It showed that carbon was a key ingredient in Mercury's recipe. And that led a few scientists to ask a really bold question: if there's graphite on the surface, what form could that carbon take under the mind-bending pressures deep inside the planet? This is where the story shifts from known science to a fascinating hypothesis that could rewrite our understanding of Mercury's interior. What happens when you take a planet's worth of carbon and squeeze it? The idea of a diamond layer on Mercury isn't just a wild guess. It's a hypothesis born from laboratory experiments that try to mimic the hellish conditions deep inside a planet. At the boundary where Mercury's rocky mantle meets its iron core, the pressure is immense. Scientists wanted to see what would happen to carbon under those exact conditions. In high-pressure labs, they took graphite and subjected it to the intense heat and pressure believed to exist there. And in those simulations, something incredible happened. The humble graphite transformed, its atoms rearranged into a perfectly ordered, ultra-hard, crystalline structure. It became diamond. The proposed mechanism goes something like this. In Mercury's early history, its massive liquid core was a molten mix of iron, sulfur, and a whole lot of dissolved carbon. As the planet cooled and its inner core began to solidify, the remaining liquid became supersaturated with carbon. Kind of like how sugar crystals crash out of water when you make rock candy. But instead of sugar, what might have crystallized out of this metallic magma was pure carbon in the form of diamond. Because diamond is less dense than the surrounding molten metal, these newly formed crystals would have floated upward, potentially accumulating over millions of years into a layer at the top of the core. The models, while speculative, suggest this process could have created a solid layer of diamond, perhaps miles thick, blanketing the planet's entire core. So we have a fascinating, if unproven, hypothesis. But does it solve anything? Well, here's where the idea gets truly compelling. According to the scientists behind this hypothesis, a diamond layer might just explain Mercury's biggest mystery: its stubborn magnetic field. Diamond isn't just hard, it's also an incredible thermal conductor, moving heat better than almost anything. The theory suggests that if a diamond layer is sitting on top of the core, it would act like a giant super-efficient heat sink. It would draw heat out of the liquid outer core very effectively, pulling it away into the mantle. This rapid heat loss could be the secret ingredient that keeps the core churning. By constantly cooling the top of the outer core, the diamond layer would boost the convection, the vigorous stirring of liquid metal that generates a magnetic field. In this elegant scenario, the diamond layer would be the cooling system for a planetary engine that should have died billions of years ago. It's an idea that connects the surface chemistry with the planet's deepest mystery in a single unified theory. Okay, it's time for a major reality check. The idea of a diamond-encrusted core is spectacular, but it remains a highly speculative outlier hypothesis. It is not a mainstream consensus view. It's a compelling model that fits some of the data, but there is no direct evidence, no seismic reading or deep planet sample to confirm it. Most researchers are exploring other explanations for Mercury's magnetic field, often focusing on the unique composition of its core, like its high concentration of sulfur, which could act as an antifreeze to keep the outer core molten without needing diamonds at all. The diamond planet idea is an exciting what if, a testament to scientific creativity. But it's just one of several competing ideas, and a major test is coming. Right now, a joint European and Japanese mission called Bepi Colombo is hurtling toward Mercury. After a delay, it's now set to arrive in orbit in late 2026. Bepi Colombo is the most advanced mission ever sent to the solar system's innermost planet, carrying instruments that will map Mercury's gravity and magnetic field with mind-boggling precision. Bepi Colombo isn't specifically designed to go diamond hunting, but by giving us our best ever picture of Mercury's interior, its data will put powerful new constraints on all theories about the planet's core. The results could lend support to the models that predict a diamond layer, or they could point scientists in a completely different direction. So is Mercury a diamond planet? The honest answer is we don't know, and right now it's unlikely. The evidence is indirect, based on compelling but unproven models, but the very fact that we can even ask this question is what makes science so thrilling. It transforms Mercury from an overlooked ball of rock into a world of intrigue and immense possibility. It's a reminder that even the places we think we know best can still hold profound secrets. The journey to understand Mercury shows the scientific process in action. We observe, we find things that don't make sense, we dream up bold hypotheses, and then we go get the data to see if our wild ideas hold up. Whether its core is blanketed in diamond or something else entirely, Mercury has already given us a gift. A fantastic mystery that pushes the limits of our imagination. What do you think? Is this a plausible theory or a beautiful piece of science fiction? Let me know your thoughts in the comments below. And if you enjoyed this trip to the heart of a mysterious planet, be sure to like and subscribe for more deep dives into the cosmos. Thanks for watching,